Good morning, everyone. I welcome you all for the second day FDP on healthcare data analytics using artificial intelligence and machine learning. We'll be beginning our second day with the session one. So we'll be starting with Dr. Sanjeev Kubakaddi's session. It's my pleasure to introduce Dr. Sanjeev Kubakaddi. Dr. Sanjeev is a successful entrepreneur representing the aspiration of a new, emerging, and challenging India. Frontier do not daunt this new breed of entrepreneurs. They appear to them as invitations for a newer ascent, a more arduous climb, a mightier push. These invitations appear to them as a reward themselves. Sanjeev comes from humble background, born and brought up in a village in northern Karnataka. He is constantly aware of the work that needs to be done to bring prosperity to villages such as his, and this helps keep his feet firmly on the ground while the mind goes on to conquer newer zeniths. His hard work has been recognized by Economic Development Forum, New Delhi, and it has been awarded him the Rashtriya Udyog Ratna Award in the year 2012. He is also a recipient of Mother Teresa Excellence Award 2013, represented by Integrated Council for Socio-Economic Progress. Sanjeev's biography is included in the Markowitz Who is a Fool in the World 2014. In the course of close to 2 decades in industry and academy, brought to his sharp focus the need to bridge the wide gap between industry expectation and academics. ITIE Knowledge Solutions was conceived with the aim of bridging the gap. It has been serving the cause of both industry and academia since 2006. In that, more than 5,000 students, faculty, and professionals from 14 countries have been trained on various domains and tools. The biomedical data acquisition systems, Medilogger, is a multi-channel, multi-parameter data acquisition system developed by ITIE. It has found wide acceptance in research and development organization and academia. It has kept excellent relations with the client, which includes, among the others, Tata Steel, Infosys, General Motors, Aerospace, HCL, PT Lens, and so on. Sanjeev has been active in the industry and academics and has always strived to be in the forefront. As the founder of ITIE Knowledge Solutions, he has been successful in making the company a trusted name in academia and industry for training and solutions in the biomedical signal processing, image signal processing, digital signal processing, control system modeling for automotive and aerospace applications, and so on. He is on the governing council of many academic institutions. He is nominated academic council member of the Bangalore University. In the past, he has worked in reputed organizations, namely Indian Institute of Technology, Delhi, Symphony Services, and Novatium Solutions, and contributed significantly. Sanjeev holds an MTech degree from Vishwesvaraya Technological University, Karnataka, in which he had secured the 3rd rank. Sanjeev has been awarded PhD from Jain University. His area of expertise in medical image processing. He is also an active member of IEEE and many other professional organizations and group, and has authored many international peer-reviewed papers and given presentation in various conferences of repute. Sanjeev is a renowned trainer in the area of signal processing, image processing, and biomedical and control system. I welcome you once again, sir. Over to you, sir.
Yeah, very good morning to one and all. Thank you, Professor Uttam, for the introduction. So let me share my screen and start. If something goes wrong with the connectivity, I request you to ping me on my mobile so that because I'll be in a flow. So
Yes, sir.
I hope my screen is visible to all.
Yes, it's visible, sir.
Right. Very good morning to one and all who are participating in this faculty development program. It's always a great pleasure to be a part of COEP and AICTE driven Atal FDPs. I strongly believe these FDPs definitely help to understand what is happening in the outside world as well as what is happening in the your own area of expertise or the research focus areas that you will all be working on. So the topic that I have picked up is very close to what we have been working for the last 20 years, though it's a very wide domain today, I have tried to focus more from the applications perspective, more from what is happening outside the research world in the commercialization of these softwares, in the utilization of these technologies that you researchers develop. So that would be the focus, and I firmly believe the other speakers will be talking about the theoretical understanding of artificial intelligence algorithms, the machine learning algorithms, the deep learning algorithms. So they will go deeper into the theoretical understanding or from the algorithm perspective. I will try to confine my focus towards the applications and the opportunities that artificial intelligence has thrown, and I will focus more into healthcare in general and probably the medical image processing in particular, how it is helping even as in today. So I run a company called as ITIE Knowledge Solutions, which I started along with two more of my friends from IIT Delhi. ITI Knowledge Solutions focus is to develop in-house innovative healthcare solutions, as well as collaborate with people outside the world and bring the technology to India and to the EUs. So you can visit us at itie.in to know about the products, the research area, and the solutions that we are into. Let me begin with what AI is offering us today. Though this statistics is 2019, it has not much changed. If you see the first image on the left top corner, close to 4 billion USD has gone into the AI healthcare startups. Close to around 35,000 crores in INR. That's the kind of investment that has gone into the startups who have picked up the AI for the healthcare. There are many companies in India and outside India who are focusing on AI as an enabler for providing the solutions in the healthcare industry. So when I say healthcare, the medical image processing is one of the major radiological solutions where AI is playing a role. Who are all the big players? You name any bigger service providers or the innovators in the world, they are in this race. Amazon is into it, Microsoft is into it, Facebook, which has changed its name recently, few weeks back to Meta. Meta itself is going to be a big name in the AI based as well as the virtual reality based space. Google, IBM, Apple. So all these big players are playing a role in the applications of AI, and the focus has been more into the healthcare sector. So that's the core area. So if you see the overall innovations in the medical and biological engineering, it started from quite some time. If you look at the 1950s, when the X-rays came into picture, and I'm very sure you have a understanding of how a X-ray machine looks like. I will show you a different X-ray machine that probably you would not have seen so far, I assume, because we recently launched it in India. A highly portable, handheld, the safest X-ray that I am carrying it with me right away, which I'll be sharing it. So from 1950, the artificial kidneys, we had started understanding the ECG, electrocardiogram, the heart functionalities. the pacemakers. If you move into 1960s, you have the ultrasound as the biggest innovations. And if you move on to 1970s, we have the CTs, and then endoscopy began in 1970s. 1980s, we started seeing the magnetic resonance imaging, the MRI, the laser surgery, and so on. And today we have been hearing about genomic sequencing, the PET imaging, position emission tomography imaging, the image guided surgery, the robotic surgeries. They're all in. In all of these gambit of applications, the artificial intelligence is playing a vital role in the back end. So what are the subsets of this artificial intelligence? So you have a bigger AI wherein you use the computer, its ability to reason as humans. The way I perceive the things, we want the computer to perceive it. In the subset of this AI, you have a machine learning where computers have the ability to learn without being explicitly programmed. That's where the machine learning algorithms comes. The subset of that is the deep learning, where the network is capable of adapting itself to a new set of data so that you have a faster results based on the learning. So it has grown over a period of time, and it is growing as and when we are talking to each one of us today. There is a work that is being happened. There is applications being used in the field. If you have heard, the WHO announced by 2025 we want to eradicate the tuberculosis. TB is a silent killer. For the last 2 years, 1.5 years, or starting from January 2020, we all have been experiencing what this pandemic can do to all of us. We have experienced it. We have seen, we have heard what this pandemic has done to the human community. So because of this COVID surge, the other patients who were suffering from the chronic diseases or a prolonged diseases, like let's say a tuberculosis, have been suffering for the last 2 years. We have not been able to attend anybody other than the COVID, because all the hospitals are flooded with the COVID patients. So when you see, that is where the need for AI or the applications of AI comes into picture. When you have less number of experts, then the technology is the only solution which can enable us, or which can reduce the burden on the experts. For example, on the radiologists. And I'm very sure in the last 1.5 years, each one of us who is attending this program would have visited the CT room for taking the chest CT, or you would have gone into the X-ray room for sure. Either you would have gone it yourself, or you would have taken your loved and dear ones for the scanning. And the enormous of scanning and the amount of pressure or the amount of work that is on the radiologist is huge. They will not be able to prepare a report in many cases. You would have experienced it in the peak of the hour during this COVID. They would have just taken their CT and they would have orally told you, okay, you are fine, or there is some issues with the chest infection, the chest is infected 40%. They are not in a position to give the reports. That's the kind of work schedule that the experts are working with. And you can visualize how AI can ease out, or how AI can reduce the workload on these experts. we firmly believe that, these technologies, it is hard to replace an expert. It is hard to replace the human beings. Let's not be under the assumption as of now that everything will happen on its own. May not be true in the near future, at least. We require the expertise intervention. We require the expert's opinion in concurrent with what your AI is giving the results. However, this AI technology or the usage of the technology in the healthcare is certainly going to enable the doctors to see the patients in a different way, different perspective. They can manage their time effectively because of the shortages in the expertise, because of the shortages in the human resources. The technology comes, and AI, without any doubt, is playing a very, very vital role, and it is going to play much more role in the days to come. So what is artificial intelligence? I am very sure you have been hearing these definitions, or many of you might be working in AI domain for sure for your research work. I'll not go deeper into the theoretical understanding of it, but the general definition of artificial intelligence is using the computer to model the behavior of the human. The way I understand, we would like the computer to understand. So you wanted to model the intelligent behavior with the minimal human intervention. The theory and development of computer systems able to perform the tasks that normally require human intelligence, such as visual perception, speech recognition, decision making, and translation between the languages, and so on. So the artificial intelligence is a broader terminology wherein we wanted to use the computing ability to develop the models which behave like the humans, which interprets like the humans. So that is where the work broadly is into. And you can put AI broadly into two categories. One is the knowledge-based approaches and the machine learning approaches. So the knowledge-based approaches that compute the reasons about the statements deemed to be true about the world. So an operator or a programmer implements such statements in terms of rules. So it's all rule driven. Okay, if it is like this is what is the output. Or if the area of coverage is so much, then the tumor size is so much, the volume can be computed. So wherein you have a logical inference to do the analysis of this data which has been captured from the real world. As a subset, the machine learning. So the machines and computer programs, they are capable of the problem solving. They're capable of learning. That is where the training plays a very vital role, like a human brain. So that's another area of where we work predominantly. Um, the brain is a very interesting part to study. We have been working on brain-computer interface. We have been working on using AI for controlling the real-world applications and so on. So if time permits, I'll just show you a couple of videos where we have demonstrated live how AI can help in building the brain-computer interface as well. So you have a NLPs, wherein you have pattern recognition algorithms, you have visual perceptions, you have decision makings as a part of the natural language processing algorithms. So ML is one of the most exciting areas for R&D of computational approaches to automatically make sense of data. I'm very sure the other speakers will talk about the different algorithms in the ML and AL in general. There are advantages of the machine learning or the artificial intelligence in general. This machine is not susceptible to the sleep deprivation, the distractions, the information overload, or the short-term memory loss, what we all of us experiences. So machine doesn't have these kind of problems. So that is where in the days to come, with the development of the new algorithms, the efficiency with which we train, we are very sure they will be outperforming the way we normally perform. The another subset that we saw is the deep learning. It's a machine learning technique or algorithm that derives much more complex representation or the recognition of a concept out of a very simple concepts in an incremental manner. It learns on its own from the data set that you would have trained. So that's where the deep learning algorithms are taking us. And I'm very sure you have seen the driverless cars from Google. You have seen the advancement in the virtual reality and augmented reality, where these algorithms are playing bigger roles. So this is one of the applications of deep learning, where an image of a person can be recognized through a simple concepts such as the corners, the contours, which in turn are derived from the edges and strokes, etc. So I'm very sure people who have been working on the image processing, you will understand what is an edge, what is a corner, what is a contour, and so on. So the deep learning algorithms extracts these as the features, and once it is trained, then you can use it to do the recognition. So that's one of the applications of the deep learning. So at each level of abstraction or complexity is processed by a ladder of hidden units. I'm sure the moment you hear the word hidden layers, what comes to your mind is the ANN, artificial neural networks. So where you have the middle layers or multi-layer networks for learning. So that's where you have an input layer and you have the output layer and you have different hidden layers. So each layer, processes the smaller abstraction of the image and fits into the next layer so that there is a continuous learning in it. So that's where the fully connected neural network comes into picture. The learning, as you broadly understand, can be classified into supervised and unsupervised learning. So in a supervised learning, the raw data, typically the input features, the features are again classified into the spatial domain or the frequency domain features. So you can, the shape could be a feature, the edge could be a feature, the wavelet decomposed coefficients could be a features. So these features from the raw data are labeled, and then the algorithm is trained to understand or recognize the meaning of these features. So you extract the features from the raw data, you label it, and you train the algorithm to understand or recognize the meaning of the input. The algorithm is tested and evaluated against unlabeled raw data to see how well it makes accurate predictions. So that is where the supervised learning is. What happens in case of an unsupervised learning? The raw data are unlabeled. In this method, the algorithm is designed to discover the patterns that are not known in advance, even by us. And this kind of a training, this kind of a learning, as we understand, requires very, very large and complex data sets. So it is a kind of a continuous process of learning, recognition, improvement in the process of learning. So that's where the unsupervised learning happens. So broadly in 2018, this unsupervised learning is put in the form of an understanding. It is based on the association rule mining is what is used in the supervised scenarios to discover the interesting patterns. The grouping of data automatically split the data set into the groups according to the similarities. You go by the reason growing, you go by identifying a similar region. So you grow and then make the grown area as a portion of the data, and then continue to see whether it belongs to the already known data or is it a different one. So you go on classifying the data set. The another subset that we saw is the machine learning. So the expert humans disconcern and encode the features that appear distinctive in the data. For example, the feature engineering, where we have been extracting features from the data set that is given to us. Before even you extract the features, you are trying to standardize the data set. The Stanford had spent close to around 1 billion USD for standardizing the data set, close to around 7,000 crores INR has been spent only on the data collection and making the data set so that the entire world can use the data for analysis. So it is still a challenge in terms of the limitation. I'll talk about it at a later stage. The algorithms are trained to perform the tasks by learning patterns from the data rather than by explicit programming. So that is where the machine learning comes into picture. So machine learning algorithms uses they learn from the data and make an informed decision on what it has learned. So that is where you are making the machine to learn and take a decision on what it has learned, to do the predictions, to do the analysis. So to summarize the three subsets, you have artificial intelligence, which is a broader area. A subset of is a machine learning, where the machine are trained based on the data sets, based on the features that you extract, and based on the learning, the algorithms makes the decisions. And the subset of that is a deep learning, where the untrained dataset, untrained network is able to detect using the deep learning. So that is where it requires a complex data set. It requires a very, very big data set for deep learning to make it successful. So in general, what all machine learning is doing in the healthcare industry, it is improving the accuracy of the diagnosis, the prognosis, and the risk prediction. It is helping us to optimize the hospital processes such as resource allocation, the patient flow, the the bed allocations, and so on. These algorithms are helping us to identify the patient subgroups for classifications, which will help you for a personalized, which will help for the precision medicines. The database, whatever is being collected, it is helping us to build the medical knowledge for clinical diagnosis, guidelines are the best practices, and so on. AI or machine learning in general is helping us for automatic detection in the pathology, radiology, and so on. We worked on multiple applications for lung cancer detection, early detection of knee osteoarthritis, the glaucoma identification. There are applications in the pathology as well. So in all of these areas, the artificial intelligence, the machine learning, or the deep learning algorithms are helping the healthcare industry. Overall, there is an improved quality of care while reducing the healthcare costs. The reduction in the healthcare cost could be a debatable point, but the general understanding is as and when you use the technology, the cost should come down, and I'm sure in the days to come it is going to happen. But as of now, it is not happening. The cost of healthcare is increasing because people are exploiting the technology. So the moment you bring in a new technology, your healthcare costs are going on, seeing that we have done a huge investment. So that's the separate point of discussion. I'll not get into that. But as a technologist, as a researchers, what we feel is as and when we have done the new development, as and when we have contributed to the development of the healthcare, we expect the cost to come down. And I'm very sure it is going to happen, because how long these hospitals can exploit us? Once the government takes up the lead, we are very sure we will have affordable healthcare in the near future. It's a summary. The machine learning algorithms, we classified them into supervised and unsupervised. You have a reinforcement learning as well, the use of sequences, punishments to form the strategy for operation in a specific problem space. Probably I will take up questions at the end. Probably we can discuss in detail the applications, because the domain is very wide and you can visualize any domain. Probably we can bring in the AI to see how it can enable us to do the things, whatever we are doing, in a better way, end of discussions. So the features. So typically we extract the different features from the data and we do the analysis. Based on that, you can do the classification. You can do the classification of the data, whether it belongs to the healthy or non-healthy, whether it is a arthritis case, or it's a non-arthritic case, or it's a potential arthritic case, or it's a tuberculosis case, or it's a COVID case. Some of the case studies, I'll talk about it, what we used AI and what we have been using even today on the field. So these are the different machine learning algorithms, the features that you extracted, what is the kind of input, what are the outputs. So that is where it is fixed. So what all you wanted to extract from the input to recognize given as an output. So you wanted to classify. Okay, so that's where these machine learning algorithms are helping us to classify the given input, what it belongs to. So this is an ongoing discussions, the human versus computer. Yes, the systems are making a lot of progress. They are coming very, very close to what we think, what we do processing, the analysis, and that's the good development that is happening. So on the deep learning technique or algorithms, so that derive much more complex representation, as we saw, or the recognition of a concept out of a very simple concepts in an incremental manner. That's where the deep learning is derived. So it's a subfield of machine learning, and machine learning is a subfield of artificial intelligence. There is no feature dependent here in the learning. Instead, the algorithm learns on its own the best features to classify the provided data. So the structure algorithms in layers to create the artificial neural network, the hidden layers, what we saw in the multi-layer network, are used to learn and make decisions. So that's where the deep learning. I'm sure the people who are working on the deep learning is the CNN, the convolutional neural network. And we being in the industry, we firmly believe that whatever terminologies that we are hearing, they all have been derived from the core fundamentals. For example, this convolution neural network. I'm very sure with all the background that we come, the electronic, electrical, or computer science, we are very sure we have done deep dive into the convolution algorithms that we saw it long back in our engineering. So the convolution algorithm is a base for the entire signal processing. The y of t is equal to x of t convolved with h of t for a continuous convolution algorithm that we have seen it. For a discrete one, we have seen it as y of n equal to x of n convolved with h of n, and we are aware about what is the h of n, what is the x of n, what is the y of n. Y of n is essentially the output, the x of n is the given raw input, the h of n we call it as impulse response of a filter, and then we replace this convolution symbol with the summation. I'm just orally reading it. I don't have equation to show you, but I'm just trying to recollect. Yeah, slide is here only. I'm in the convolution. I am reading out the equation for you. So you know, the convolution is the base for understanding the filtering. It's a base for understanding the signal processing, and the CNN also uses this algorithm as the base. So our features could be the intensity, it could be the edges, it could be a filtered one, it could be a texture, and you have got different types of classifiers. You have a KNN classifier, probably I'll show you one algorithm. You have a support vector machines, the SVM, or you have a random forest algorithm for RNN, and you use all these classifiers to classify the data based on your requirements, and all this fed into the deep learning algorithms to make it learn. So this is what we discussed, ANN. So let me focus more on the data set. I spoke about it. One of the biggest hurdle as a researcher, I'm very sure many of will ask me about this as the question is the data set. as academicians, probably you will not understand the kind of effort, the kind of investment that goes into the data collection in the industry. The data collection is the biggest task than designing or writing the algorithms. People are trying to standardize the database. I am talking about the image processing data set in this case. People are trying to standardize the data sets so that the researchers across the globe can use and build an algorithm so that everyone gets benefited from the algorithm development that we all are in. So some of the image data sets that are available for medical image processing are listed here. If it is not visible, you need to excuse me because I just expanded this image. ImageNet is one such database that is available. MNIST, Pascal. Then your YouTube also has got close to around 8 million videos for the video topics, for understanding the video recognition, video processing, and so on. Most of these bigger players, they are also contributing to the data set. So this DeepMind Google works with this NHS from UK. So they have close to around 1 million eye scans, in the database. So similar to NHS, NHS is a national health service based out of UK. I'm very sure you would have seen the NHS logo during the COVID times very predominantly. So companies like Google, they work with the healthcare service providers for the data so that they can standardize the data for different applications. Again, the medical image processing is very broad. What all you can do in image processing, probably in the next slides, I'll talk about 3-4 topics where all, we have been using AI and we ourselves have used AI in the medical image processing area. So you can see here, MGH, Massachusetts General Hospital, and Brigham and Women's Hospital, they have spent more than 1 billion USD on the data collection infrastructure. So it's a huge investment as far as the data collection and standardization of the data is considered. I'm very sure as researchers, you find it very difficult to get the standard data set when you start your research or when you started your research. So that's the biggest hurdle that we all have to cross, and it's a challenge even today, but a lot of people are working on standardizing the data for our benefit. So it's an ongoing process, and I'm sure you might also be thinking about standardizing the data, because unfortunately we don't have a Indianized data set for most of the research work that is happening in India. We always pick up the data sets from outside and we build an algorithm for that data set. We are not really sure how it really works for Indian population. So we faced it in the beginning of the COVID in January 2020, where we had a AI-based algorithm for automatic detection of the chest infections, the percentage of the infection. So most of these algorithms, we had trained it on the South Korean database. So when he started using it for us, so the efficiency was really low. So it took us a lot of time to collect the data and fine tune the algorithms, and then do a better prediction. It is still a challenge. So what I'm trying to say is, there is a need for standardizing our data sets. Whoever is working on multiple areas in the AI domain, there is a need for standardizing this data sets, because we predominantly have worked on somebody else's data set, as it is a painful uh, you know task of collecting data, standardizing the data. But as a team, we need to focus on that. We need to standardize our own people's data. We cannot work on somebody else's data and say, okay, my algorithm is working, which we have been doing it for a long time. So I think it's a high time India should have, our own data sets for each of the diseases that we come across, whether you name, whether it is a brain, heart, name any part of the body, we should have a classified data set for all, so that we can build algorithms and then do it. Interestingly, in the artificial intelligence space, the Indian startups are also doing good. If you see the last 3 years statistics in India, Indian companies have got the investment from outside close to around 500 crores INR, to the tune, at least around 6 to 7 companies are doing good, where they have got the investment. They're trying to get deeper into the Indianized data, but there is still a scope for the standardized data set. So the radiologists are slowly using it. There are resistance from the radiologist, because they feel that AI will replace the radiologist, which is not true. So whenever we interact with the radiologist, we say that AI algorithm is not to replace the radiologist. So whatever algorithm that we have developing is only to aid, is only to reduce the time consumption of their analysis. So we will give them a report and they will validate it, or they will cross check it, so that the burden on them can be reduced. So that's the uses that is happening as of now. I'll talk about the chest X-ray, which we have been working on very, very predominantly for the last 3 years. It could be liver and could be characterizing the pulmonary and so on. So in terms of detecting, we have been working on the articulation of knee osteoarthritis, the is for tuberculosis, even in COVID also. I'll show you 1 or 2 reports soon. So AI and the future radiology, they are in race for sure. So we need to commercialize as much as possible the algorithms that exist. The challenge that we are seeing is the Indianized data set for training. We still have the challenges, but we are trying to overcome those challenges by making the algorithm intelligent to learn it from the data set that we are having it in-house. So there is a lot of focus even from the medical fraternity. A lot of radiologists are attending our workshops to understand how AI can help them. So they have started accepting it, though there was initial resistance from them. They are slowly accepting that, oh yes, AI is an enabler for me as a radiologist. So a lot of focus from the medical fraternity is also seen these days onto the AI applications. So specific to medical image diagnosis, the automated analytical systems, they have started to emerge as database systems that enables the scanning of medical images to be performed on a computers, and the construction of a big data. So as we saw, the deep learning artificial intelligence architectures have been developed and applied to the medical images, making a high precision diagnosis possible today. So if you see the overall structure of this, you have a data, you have an artificial intelligence algorithm, you have a machine learning algorithm in it, you have a deep learning algorithm in it, and you have a diagnosis out of it. So you have a lot of algorithms, the RNN, the CNN, the Google Linet, and so on. And then the machine learning algorithms, if you see this, you have a supervised classification, unsupervised classification, the learning. And then in a general AI, you have a technique which enables the machines to behave the way the human behaves. So you have a broader data, and inside you have a AI layer, inside you have a machine layer, inside you have a deep learning layer, inside you have a diagnosis. So this summarizes the entire medical image diagnosis methods using the AI. And if you see the flow chart, you have data, you have the modeling, you have the training and verification, and you have the diagnosis as the vertical. So in the data, the labeling, the standardization. Please let me know, Professor Uttam, if the audio and there is a clarity.
Yeah, it's clear, sir. There is no issue at all.
Okay. Okay. So you have the vertical data, so where you have to label or you have standardization, you are putting a bounding box, you have a segmentation, the augmentation patch extraction, the anonymization of the database where you label it. So when it comes to modeling, you have different architectures. You have CNN, RNN, RBM, the batch normalization, active pooling, and on the training side, you have different types of training and verification methods, and you have a diagnosis reporting system. So that's the flow chart. So when it comes to applications of AI in medical image analysis, the applications are enormous. However, broadly, the AI, the AI has these applications. So you can use the artificial intelligence in the brain imaging. You can use artificial intelligence in the chest imaging. You can use artificial intelligence in the breast imaging to detect the breast cancers, to detect the anomalies. You have AI applications in cardiac imaging, musculoskeletal imaging, and so on. So in brain research, using the artificial intelligence, a lot of studies have been conducted in the field of Alzheimer's disease, for example, in the field of anatomical segmentation, in terms of tumor detection, and so on. If you also see, this is another area, the neuroengineering. For the last 3 years, if you see the kind of investment that has gone, we keep a track of it because we are in the same domain. For the last 3 years, the AI startups in neuroengineering, in Europe alone, I have a data from Europe because most of our partners have got the funding in the last 3 years to the tune of 100 crores in INR, 200 crores in INR, for building these AI algorithms for brain analysis. So it could involve identification of the tumor, it could involve identification of the anatomical segmentation of the brain, or it could be the Alzheimer's disease, that's one of the applications of the AI in the brain imaging. So when it comes to chest, as I mentioned in the beginning, by 2025, we have a mandate to eliminate the tuberculosis, though this mandate has been pushed for the next 3 years because of this COVID in the underdeveloping countries like African countries and all, where the tuberculosis are more in number. COVID has added to that, and chest imaging, believe me, is becoming a big uh, buzz in the industry, where a lot of companies are getting into AI-based solutions for automatic detection of the chest infections. So the CNN-based algorithms are helping us to detect this, the tuberculosis, the COVID, and so on. The AI in breast imaging, predominantly the mammograms are two-dimensional, and the number of data is very, very large, the mammograms, and it's a painful test for the woman. So these images using the AI can help, by adopting the deep learning algorithms. It can avoid the pain that we experience during the mammogram. And also there are limitations of mammogram, where the breastfeeding ladies, they will not be able to undergo quite often because of the radiation and so on. So AI can help, so that by learning we can reduce this pain. And so on. In the cardiac imaging, the applications are enormous, and also in the musculoskeletal images, wherein the 3D CNN architecture has been developed and deployed in automatically performing the supervised segmentation of vertebral bodies from the 3D MRI spine images. So where people are working on MRI images as well for the deep learning algorithm training and predictions. So as we understand, there are plenty of benefits of artificial intelligence domain. I'll just read out for the sake of summarizing this. So AI can definitely assist the physicians, which we have experienced it from ground, because we have been interacting with the doctors at different levels, at tier 1 cities, tier 2 cities, even tier 3 cities, where with a village population of some 2000 and so on, where we are working for these tuberculosis identification and detection. So it is helping. Doctors are saying that yes, it is enabling us. So AI is helping them in clinical decision, for better clinical decisions they can take. You can correlate the human judgment with the algorithm judgment in case of the radiology applications. Its AI can be availed 24/7. So most of these deep learning, the machine learning algorithms will be on a cloud, as you all understand. So you can run these algorithms round the clock. So it's like a 24/7 availability of the expert. So that's the advantage, because it's a machine. So AI will definitely help in the early diagnosis, the early detection, or the preventive healthcare is another area of interest that you can focus on. Anything that you wants to detect early is a kind of a gift that we can give to the human society. Once you have something, diagnosis is a different area of of concern. Diagnosis is different. If you get into the preventive or predictive, then there is nothing like that. Well, before the disease, if we are able to detect, that's where most of the algorithms are focusing, and all these developments in the AI is definitely helping us for early detection. So if you go for a angio CT, probably we will come to know when there could be a possible heart attack. So for a potential, cases, if you undergo a angiogram, CT angiogram, probably it will predict. Okay. So that will help the cardiologist to suggest the patient so that we can avoid the cardiac arrest or the heart attacks. So the prediction of outcome of all the diseases as well as the treatment is an advantage. The feedback on the treatment is possible here. It can reduce the diagnostic and therapeutic errors. Possibly AI is already helping it. Increased patient safety and huge cost savings associated with use of AI, and some of the AIs are artificial intelligence algorithms. If you are aware about it, 2 months back, the US FDA, the highest certifying agency, FDA, recognized AI algorithms as the diagnostic category. So whatever AI algorithm tells, now it is at par with what radiologist predicts or extracts from the images. So it's at par now. If US FDA has been granted to the AI algorithms. So these are the benefits of the AI algorithm for sure. It not only in the the medical image processing or the data perspective, it is also helping us on the devices side. So most of our devices are AI enabled. As soon as I flash, probably I have a video to show, you'll understand how the medical devices are also playing a bigger role. The more portable, more battery operated, AI enabled hardwares. So especially in the wearable technologies, I'm very sure the AI is a big time addition in the hardware design and development. So you have different networks like Bluetooth, Wi-Fi, RF, and so on. So used to transmit the data. That's the transmission side. Use of robots to deliver the treatment or the robotic surgery. We have already seen, and it's been used in India. We are very sure the design and development of the robotics also is enabled by the AI development. So we have seen robots walking on their own, taking a decision where to turn, when to turn, and so on. So it's a very interesting field to watch and contribute. And we are also excited as researchers in the industry to commercialize as many algorithms as possible so that it will benefit the this entire society. So the growth is enormous and growth is visible. In 2019 to 2020-21, the investment that has gone into the AI-based startups in the healthcare, that itself is a significant pointer towards the growth and where the AI is driving the healthcare. So that itself is a big indicator to substantiate the growth. And we have been seeing the applications widening, not only in healthcare, in speaker recognition, in automated guided surgeries, you name any area, the AI is capturing the applications. Having said that, it also comes with the challenges. It also comes with the limitations. It also comes with the shortages. The one of the greatest challenge is the developmental cost, as it's a new technology, and any new technology development will be a huge investment. So developmental cost is one. The integration issues. Now, if whatever my AI algorithm predicts, that I have a tuberculosis, I may not have a tuberculosis. So if AI does the wrong prediction, or if there is an error in the AI algorithm, who should be held responsible? In case of the doctor predictions, the doctor is the authoritative, the doctor is authorized to predict. So we go by their prediction. In this case, the algorithm, the ownership is still an issue. So there is a reluctance, as I said, among the medical practitioners to adopt AI. In fact, you will be surprised to hear that I keep getting a lot of calls from the radiologists who are a good radiologists saying that, will AI replace me? Will AI take away my cake? We always emphasize whenever we give a software demonstration to the radiologist, whenever we go, we say the first sentence that AI is not to replace the practitioners. AI is only an enabler to the practitioners. AI is going to reduce your burden. AI is going to add on the value addition to whatever you are doing. AI will help you to prepare the faster reports. And if you happens to go to any radiologist, I'm very sure which part of India you are in, but the experience is the same. We have to wait for at least around 3 to 4 hours for an MRI report to come, at least 2 hours for a CT report to come, and so on. So the wait period is too much. So that is the reason is the number of radiologists are low, and they have been loaded with too many images to do the analysis and do the reporting. So it's a challenge. So there is that is one of the challenge that we experience it on day in and day out whenever we go out. Data privacy and security is a challenge, of course, and with the advancement in the computing environment, the cyber security threats are also increasing equally. With these kind of pandemics in place, I'm sure you would have heard a lot of people losing money online for they are becoming victims of cyber securities and so on, and the healthcare data being the highest secured data, so we do have a limitations on the data privacy and security with its ongoing challenge, and there are solutions that exist for that. Training is another big challenge. Apart from this, if you ask as a researchers to what could be the biggest problem in the artificial intelligence or machine learning algorithms, it is the labeling of this data. It is annotating the data. For example, see, the algorithm will be able to detect only if I tell, okay, you call this as um, the reason of interest. So the labeling of the large data sets becomes a big obstacle because we require the radiologist to do the annotation. So all these AI companies who are emerging now, they have hired large number of high-paid radiologists on their board to assist them in annotating, in labeling these data so that my algorithm can perform better. So that's the biggest problem. And on the advantage side is we have enormous advantages. The speed and the consistency of AI is unmatchable with the human. So AI can access a massive number of variables faster and more consistently compared to the human beings. So the speed and consistency is the greatest advantages. It will be a big enabler to the radiologists, and there will be a overall improved objectivity with which the diagnosis is done. So that's the advantages, and yes, it comes along with some limitations. These limitations are being worked on day in, day out to overcome so that we move towards more positive side. So is it an advantage or is it a disadvantage, artificial intelligence in the radiology? The fear has been AI would begin to chip away at jobs. That's the perception that they have, and some of them have convinced, some of them are still very, very obsessive because we are able to sell only one AI solutions in India for the last 1.5 years. Whereas we have sold close to around 25 hardwares, but as far as the AI software is considered, hardly one has bought it because rest all said, no, we are there to interpret, so I don't need your AI software, which of course comes at an additional cost. So that's the challenge that we are facing it, but we are very sure we will be successful in convincing the medical fraternity that it's an enabler, it will not replace their job and so on. But yes, that's the challenge that we are working with on ground. So there will be initiations from the radiologists also that if we adopt early, we'll be in the race, otherwise we'll be out of the race. So that's also they are realizing it, and some of them are coming in line with the AI and then taking it positively. I'll skip this for the case studies. So this is the screen of our partners software which detects the chest x-rays. So this is the x-ray, and let me turn on my video for a while. So this is the portable x-ray that I was talking about. It's a handheld x-ray. You can just turn this on. You can just turn this on and you can set the exposure, etc. And you can just the way you take the photographs, you can take the chest x-ray. So it's a battery operated. You can see the laser here. Okay, so you have a button to click on this side. Okay, you can just click for the okay. So yeah, screen, I'll share it. I'll stop the video. You need to allow me to share the screen. Yeah, now it is coming. Yes.
Now you can share, sir.
Yes, yes, yes. I hope it is visible now.
Yes, sir. It's visible.
Okay, okay, okay. So this is the X-ray, the portable, the handheld X-ray, which can enable these algorithms. So you can see, our algorithm detects the pneumonia, the tuberculosis. We used it in the COVID case here in India. It will also label, the impacted area for the doctors to narrow down the analysis. So this is the kind of report that we get. It gives you the percentage of impact. Okay, so this is the AI based chest X-ray analysis report that comes, and um, this has to be correlated with the doctors, right? So but this enables, so you can see the clarity of the X-ray image, wherein the image processing algorithms have played a vital role. And the usage wise, I'll come back to this slides. The usage wise, I'll just run this video. So I'll stop talking. So I have explained it in the video itself.
So it connects Wi-Fi. From here, you can send it to WhatsApp or email to the radiologist or to the hospitals.
So basically there are basically there are three components in it. One is whatever I am holding, that is the X-ray source, which I showed you in the video. So this itself is a X-ray source, and I am not wearing any lead apron, and I am not taking the X-ray in a closed environment because this is the lowest dose X-ray that exists today, and we have it with us now. It's a 2 milliamperes and 60 kV portable X-ray, and what this one of our employees holding is the wireless detector. So since we are taking the X-ray of a chest, so the white board what you see is the X-ray detector, or you can call it as a reflector. It's a detector, and none of them are connected through the wires. All are wireless. I am holding the device which is not connected to anything. He is holding the detector. It has not been connected to anything. It's a wireless. So the X-ray source comes from this machine, hits his body. There is a reflector, there is a detector here. The mirror image will be able to be transmitted wirelessly to the system. So what you see on the system, is the chest X-ray. Okay, so the focus we can reduce it. We have also got his hand because we wanted to show the complete area of coverage during the demonstration. So if this is subjected to the AI algorithm, this algorithm after cropping, annotating, will be labeling, will be subjected to the AI algorithm. So the AI algorithm report, the AI algorithm report, the AI algorithm report is here. So this is the algorithm report that that will be seen by you. Okay. So I'll show you one more video. Yeah. So and then I'll comment. So you can see the entire process of taking the chest X-ray, running the AI algorithm is shown by this Curie.ai, which is an Indian-based AI startup. So this is using this kind of a product. It's a tuberculosis X-ray. So the area where it is impacted is also shown there with the marker circled there. Yeah, there is no audio here. There is no audio. It's self-driven capture. So what I wanted to show was only this part of the video. So once you have the settings, you can capture, you can see that. So the X-ray is being captured here. If you notice in the previous one, right? So here, launch camera. So the moment you launch the X-ray source, you capture the X-ray, you align it, and then run the AI algorithm. So this is the report. So the report says, is it abnormal? Yes, it is abnormal, right? So whether pleural appeared, yes, they appear normal. Heart appears normal, right? So this is the kind of report, and there's a validation being done by the radiologists. Okay, I'll just this is one of our partner, Jay Weaver, is from a company called as a JLK from South Korea, and this QXR is from another company called as I hope I am audible. Yeah, I am audible. So is based on Quri, QURI.ai. It's a Mumbai-based company. They got huge funding a year back in 2020, and they are predominantly in chest X-rays. Okay, so they have this X-ray solutions. They have the CT solutions for lung, detecting the lesions and so on. So that's the for the CT solution they have. So the advanced, and it's already been used. So this is being used by Stop TB project in India, and our hardware is also being used by Stop TB projects in India for faster scanning. In order to take one X-ray, it will take close to around 3 seconds using this handheld device, and it can be taken outdoor. It can be taken to the nooks and corner, because it's not a big instrument, so patient doesn't have to come to the X-ray room, so it can go there and take the X-ray, run your AI algorithm, do the findings, cross-check with the radiologist, both the image and the report, and then move on. So for the mass screening, it is helping us a lot. So this is how the one of the report of JLK software looks like. So QXR is being used during the COVID as well in India for understanding the congestion in the chest, typically after the 4th or 5th day of your infection. So your your chest X-ray will definitely give the indication. So that's what we saw it during the COVID, and TB is a long prolonged scanning that is happening across the globe. Across the globe it is happening, and their solutions are also being used. So some of the startups, Zebra Technologies, where they have millions of high quality images, and they have developed a deep learning engine to automatically detect different medical findings, to detect the liver, lung, the bone diseases, and so on. So they have also deployed across 50 hospitals. There's an AI for health. If you are interested, you can visit AI for health. If you can Google, you will find the website. So that website summarizes all the companies who are working in the AI for medical image processing. So most of the companies, they are listed there. You can see their solutions. You can see where all they are present, what all is their solutions, and so on. So Zebra is one. Arteries is another one. So they have got a US FDA clearance, and we have also got US FDA 510K for the AI algorithms. The query also. So this is an Indian-based company. You can visit them. They are really doing good work as far as the medical image processing on AI is considered in India, and they are already deployed in the 4 hospitals or clinics in Mumbai alone. And we have been working with the different providers as a contributors. We are working as their partners. We are working as value addition, distributors. As distributors also, we are working in most of the cases. So I will stop for a while, and I'm sure there will be a lot of questions on what we spoke. So now I'm open for the discussion.
So anybody having any question? Yeah, I can unmute all and.
Yeah, that is better, sir. Let us have a discussion.
Yeah.
Because
Yes. Yeah, you can unmute and you can ask a question. Yes.
Good morning, sir.
There are one by one. Yeah.
Yeah, you had just shown us the chest X-ray. In that, beforehand, you are having some image, and you have already fed the algorithms that if this type of X-ray is there, then so and so. I mean, some abnormality is there. So,
Yeah.
it is some sort of rules are already fed. So you can say that it is a partial AI, isn't it?
Uh, it's actually a full AI in the sense that it requires a lot of intervention by the radiologist also in the process of training.
Okay,
That
so
is
it's
where
supervised.
yeah. So in the initial stage, see, there are 2-3 stages. One is the algorithm training stage itself. You need to train your algorithm. In order to train your algorithm, you need to have a huge data set. You need to have a labeled data. That's what we call it as annotation. So wherein you need to label it, right? So unless that is done, learning is difficult for the algorithm. So all this process has been already done. So for example, if you take query.ai, I am sure they have close to more than 1 crore data by now, images. So, it has taken at least around 2 to 3 years to do the training and deploy it. It's not an overnight, process. So all this process has been done, madam. So,
Okay.
yeah.
Okay. Thank you.
Once you do the labeling, once you train it, then it becomes a unsupervised learning. So the algorithm needs to learn and then do it. Otherwise, you cannot keep on training it. So the training efficiency has to be improved in the initial stages of the algorithm development and training stages. Yeah.
Okay, so thank you.
Any other question?
Yeah, there are a couple of charts, I think. Professor Uttam, you can read some of the questions. So probably you'll be able to see a bigger screen.
Yeah. I can see here.
Yeah, maybe starting from whoever has asked.
Yes. There is one question from Kashi Sai Prasad. Which approach is better to work for MRI-based images?
It's a very generic question.
Yeah.
Sai, if you can let me know what is your area of interest or what is the area that you are working on, probably we can,
Good
get
afternoon,
some.
sir. Am I audible?
Yeah, please.
Yeah,
Actually,
Sai.
I'm a research scholar working in the area of AI, sir. So currently, I'm working regarding brain tumor detection, sir.
Okay.
So for which I'm actually looking into this deep learning methodologies. Like I'm working on CNN and related methodologies.
Correct.
So my just general question is where to start? Means I'm in the beginning stage of this deep learning, sir.
Okay.
So to understand
So,
this raw data,
understood. Understood. So before you deep dive into the deep learning, first we need to learn it. How do we identify the the data and so on? Let me see whether I can quickly run one code and show you. Is my screen visible?
yes, sir.
Yes, sir. Yes, sir.
Yeah, 1 second. So typically, it should begin with the basics of your image processing algorithms, where you do the segmentation, you need the features, or you need to identify the area of interest and so on. So from there, it has to begin. So let me see whether lung cancer. I'm just running few very basic cases to understand. You're able to see my screen?
No, sir. Not clearly.
Really? Okay, I think it is taking time. It has opened up multiple images.
Yeah. That's why it's taking time.
Ah, yes. It says too many overlapping windows are causing shared content to be blocked by the operating system. Close device and so on. Oh, okay. I ran the algorithm, basic algorithm. Okay. See, basically, it should begin with understanding the data set. Uh, you know, okay, this is visible, right? This screen is visible. Is it visible? Hello?
Yes, sir. Yes,
Yeah,
sir. It's visible, sir.
yeah, I think this is the lungs image. So you do the pre-processing or whatever it is, and then apply different algorithms, segmenting and all. So this is one of the slice that we took and did it. So basically, you need to start with, before getting into the deep data learning, we need to understand the data set. We need to understand whether it is already labeled or non-labeled data, and so on. So before getting into CNN, it is better to look, because the data is everything for you. So you need to know more about the data so that you can understand what the deep learning algorithm is doing on your data. So at least you need to correlate yourself, whatever it is doing, is acceptable to you or not. So start with the image processing, understanding the image, understanding what is there in the image, because I firmly believe the fundamentals are still the fundamentals. Whatever latest technology that you talk about, they cannot be understood, they cannot be built without the fundamentals. So fundamentals are the core. Come back to the fundamentals of image, understand the image, then understanding the algorithm is another fundamental thing that you need to do. Understanding the CNN, understanding the RNN if you are using it before you run the algorithm. So you begin with the image processing, segmentation, or annotating or cleaning the data, segregating the data, or physically also classifying it if you have the multiple sets of data and so on. So that should be the first step that is there. Some of the, in one or two case studies, if I can able to run, let me see, and what all I had planned. Okay, a couple of work that we did on osteoarthritis. Let me see whether please let me know whether you are able to see my screen. So you can automatically detect. So this is part of the basics, whatever he asked. Once we have this understanding, you can get into the the deep learning algorithms for sure. So understanding the image perspective, that's the data for you. Understanding about the data set that is required, then understanding the algorithm, using the algorithm. Is the screen visible? Sorry.
Yes, yes, sir.
Yes, visible.
Okay. I just ran one or two case studies. So can be multiple. For example, somebody is working on retinal. So we have used a k-means algorithm, for example, in this case. So it's a simple one. So if we understand how this classifier works, what is the input for that? So automatic, calculation of the cup to disc ratio or cup area, what you see here. Okay, you can extract it, or only extracting the blood vessels from this original image, or only the optic disc. So this is the, I mean, I can show a number of cases because we have been working on this for last at least 20 years. So yeah, tumor, I think he asked for tumor. This is the main one. So you can begin with this so that yeah, it may not be visible because of the window size. So yes, you can begin with basically the algorithm. You can begin with the algorithm, the basics on the image and the CNN and so on. Yeah. Any other cases questions that we see? Any other questions, sir?
Sir, there is one more question from Abhishek. He's asking, sir, can you suggest application of AI in inventory management or SCM of essential medicine in hospitals or healthcare facilities?
Okay. See, basically, the pairing of artificial intelligence with inventory control has generated significant improvements for those companies that have already implemented it, especially in the hospital sector. We haven't used, but we have some case studies known where the AI is used in optimization of the inventory management, as well as in the hospitals also, where they can allot the beds or the availability of the bed, etc. It is implemented in few of the hospitals, but not in India. In UK and US, we have come across the usage of AI in inventory management, where the number of patients are less there, and it is more systemized way of working there. It might be hard here, as the physical system itself is unorganized. So it might take some more time to come to corporate hospital, Abhishek.
Yeah, thank you, sir. Sir, can you suggest any such case study that you were referring to?
I can get the name of the hospitals where it is implemented.
Yes, sir, that would be
Yeah,
helpful.
I'll find out the hospitals. Not many, because there it is easier. What we found when we observed it as a case study,
Yes, sir.
the physical process is intact there. Here, if you take any tertiary hospitals or primary healthcare hospital scenario in India, the
Right, sir.
physical infrastructure or the physical process itself is not in place.
Right.
Adding AI is really tough.
Tough to implement over here. Yes,
Yeah,
I can
and
understand
also
that.
the commercial angle is not there. See, we have been struggling, as I told you. I mean, I should not say on this as it is being recorded, but when we go and meet the doctors for this demonstration of our products, the kind of questions they ask is stunning. It is really hard to convince them. There is a huge barrier that we need to break to sell. See, first of all, struggling to develop algorithm with a huge investment, huge in human resources, infrastructure, we all develop, and when we take it to the end user doesn't accept it. It becomes really miserable. Life becomes
Yes, sir.
miserable. Yeah,
I can
but
understand
yeah,
that, sir.
slowly it is happening. We are trying to break the barrier. So, but yes, there are different problems to it.
Yeah, sir, there is one more question
Yeah.
asked by Kalai Selvi. Is there any EHR data set freely available for cancer prediction?
I will come back. Probably you can copy these questions and share it with me, sir. Specifically where it is available, I can pinpoint them. There are a lot of data. Probably I can give reference. Is there a way that I can attach a file here in the chat box? Share the file. Okay, I will share couple of review papers with the different data sets. May not be specific to cancer, but I'm sure it's a huge, data set information that I have. I will share a link, sir. I have a PDF.
Yeah, sure, sir.
If there is an option to share, I doubt there is no option to share here. Share, where is the share option? File sharing is not there, I think. I will share it with you. Probably you can pass it on to them. And there are database that are captured in that review paper, probably that will be helpful.
Yeah, there are also other questions which are related only data sets, sir. Okay, I know a couple of data set. I'll be also sharing with them in some of the sessions. Yes.
Yes. No, yeah, data set. Is there any easy?
Yeah.
Oh, interesting.
Yeah, someone has asked about EEG data set, ECG data set. Someone has
Yeah.
yeah, even like MRI data set. Yes, sir.
Yes. Yeah, the questions are mainly on data set, and whatever I
Data
have,
set, yes.
I will share it with you. On EEG also, Hemalata, I'll be definitely able to share it with you because we work in and out on EEG as well. I'll share the links.
Sure, sir.
Okay. Also tell us who do you rely on?
Sir, good afternoon, sir.
Yes. Yeah, please.
Sir, good afternoon, sir.
Good afternoon.
Sir, for medical image process, yes, sir. For medical image processing, this machine learning algorithm is more effective, or this neural network algorithms you taught about convolution, which is more accurate, which gives more accurate results, sir.
It would be
Accurate in the
hard
sense,
to, I
which is more
understood.
effective.
Yeah, I understood your question. It is hard to say.
Yes, sir.
It is hard to say, but efforts are there towards using the CNN, okay, for medical image processing. So the application of CNN has been more or less is accepted now. So it's so you can try out with CNN, algorithms.
Okay, sir. Any other, sir, processing image other than CNN in neural network?
I mean, we started way back, with KNN, K nearest algorithm or SVM. To some extent, SVM also has given. It also depends on the problem statement. So broadly, these are the classifiers which are widely used, and if you refer left right any publications in the recent publications, probably SVM and CNN are leading the researchers.
Okay, sir. Thank you.
Classifiers, yeah. Yes,
Good
I
afternoon,
think all
sir.
in one I will answer the data sets. I have a few of them. Probably I will share, and I'm sure it will be helpful to you. It could be like, done by even the companies like Google and Microsoft or Apple. So they are also working on this. And Facebook is a big time users of AI. So that's one reason why their company name is also changed recently. So it has been now Meta. So Meta, they wanted to be the leaders in the days to come on that technology as well. So that's why they have changed the name with Meta itself.
Good afternoon, sir. Sorry to disturb, sir.
Yes, madam.
Sir, your session was very informative. I just had one question alone. We have been saying about data sets for all these processing, but how could you rely on the genuineness of the data set, sir? Because we used to tell that for any processing or for any AI algorithm, we have to use only benchmark data sets because it has certain ethical issues too, because it's
Correct.
directly related with the patients. So
Yes.
can you tell us on how we can rely on the genuineness of the data set, or can you just suggest ways of getting a benchmark the data set, sir?
Sure. See, basically, as a researchers, you asked a very good question. In fact, it is applicable to all of them because the moment healthcare comes, the ethical clearance is the first thing that you need to consider. Whether you are using my data, whether you are using your own data, you have to have ethical clearance. Otherwise, the publication is you cannot publish it.
Yes, sir.
So as far as the standard data sets, see, we are all researchers, and as I said in the beginning, that these are the questions, whatever questions you have asked, I did mention in the third slide itself when I said data set is the biggest pain. You know, when I said Massachusetts hospital has spent close to 1 billion USD, which is 7,000 crores only for building the data set, standardizing the data set and so on, building the infrastructure for the data set. So it's a huge investment when you see from that. And the genuinity comes from the research groups for sure. For example, you have Stanford has a standard data set, and they have also declared the ethical clearance. They have also described about the data set, what it talks about, right? And there is a deep, somebody asked about EEZ. So there is a deep data set, DEEP, deep data set for EEZ. So you can write to them about if you are interested in working on emotions, emotion detections, and so on. So they have all these ethical clearances done, and you need to quote them, you need to acknowledge them in your paper, so that you have worked on the deep data set and so on, or the Stanford data set and so on, or John Hopkinson data set, so on. So genuinity comes from the groups from where you take it. So my request would be all these commercial organizations also have worked on these data set. I'll just show you one set of data that we collected. Is my screen visible? Is my screen visible?
No, sir. It's
No,
a
sir.
blank.
No, sir.
Yeah, blank screen. Yeah, black screen, you can say.
Oh, really?
It's visible now. Yeah.
It's visible? Okay. Now?
Yes. Yes. No, gone.
Okay. So it is not allowing me to go with multiple. Okay. So I'll stop sharing this, I think. The presentation, I'll stop sharing. Okay. Anyway, yeah, there is a share option here. Okay. I did a mistake actually. Okay. You can see this data set, right?
Yes, sir.
Yes.
Okay. So these are, I mean, we also build a data set and, of different, this is my own skull image. You can see my spect also. So this is with our machine, so we take a ethical clearance, and we collect this data for doing the analysis for the. Okay, so on the data set, just to summarize, on the data set, the genuinity of the data set depends on from where you get it. So my request is you go with the standard data set, which is widely used by the research community, like Stanford or John Hopkinson or Massachusetts hospitals, or deep data set and so on, and where they have ethical clearances declared, and they have also documented the process of data acquisition, how they have acquired, what they have acquired, the description about the data. Only such data can help you to use it in the training process. Otherwise, it will not be.
Okay. Thank you, sir.